Can you see my screen?
No, sir.
It's not visible.
It's not visible.
But me, I can see.
Can you see?
Yes, we can see.
Okay.
I can see.
Please, can you all see?
No, dog.
No.
Yes, sir, but
It's showing that there's nothing to you.
There's nothing.
I can see.
The screen
Yes.
is there, but it is blank. So he will be writing. It's just like the blackboard. So exercise patient. You can see the screen.
No. I mean, I have some question on the screen. The
The
last question
question,
is on
we
the
can
screen.
see
Can
the
you see?
question.
Oh,
The
that
question
one
is
you
not.
can see.
You can see the question.
Yes.
No, sir.
No, nothing is
No,
showing.
sir. You
Black.
can't see.
All right, I'm coming. I have to stop sharing first. So just give me some minutes. Let me. Still, it's not showing.
The screen is even off. You can't see the
It's off.
board. Yeah.
What's happening? Okay, then let me go this way. Okay, let me share ordinary. I wanted to share it differently, but is it showing now?
No, please.
Still. Who is joining the class for the first time? I think the person has brought some bad luck here.
Hey.
The person has brought some bad luck. Still, you can't see the question. The last question we work on a circle last time.
Now that it has appeared.
You have seen it?
We can see now.
Yes.
Okay.
It's now okay.
Okay. That's good. That's good. I think that was the last question we solved before we close.
Yes, sir.
Yes. Any question concerning this? Any question concerning that? I hope you have all tried it at home.
Yes, Doc.
You have tried it at home. The 12.
There is a question
down there. The 12 units down there is not the diameter. It is the length from these vertical lines, between the two vertical lines. That is the 12 units. And then each of the vertical, and this one is 8, and then this one is also 4. So the 12 is not the diameter. So those who are using it as a diameter, yes, that's wrong. You are setting your own question. Yes, somebody wanted to ask a question. Yes, go ahead.
Doc.
Yeah.
Per the slides you gave, the solution you had, I tried and I was getting different solution to what you had.
Hey, you were getting different solution.
Yes.
That's interesting. What solution were you getting?
I had 40, but you had 10 per.
10 what?
I don't know. You had 10 per, but I had 40.
You have 40. 40 what?
Yes. Pi. You said you should leave the answer in pi.
Yeah, so you have 40 pi.
Yes.
And I got 10 pi.
Yes, Doc.
How did you work it? Can you take us through? Dominic, yeah, show us what you did.
I use the same formula you showed us. So I just yes, and even people were putting the same answers there. So I didn't know how we came about the 10.
So let me show my.
So I said today
that is my solution. Yes. Why did you get square? Yes.
So I was using the right angle triangle, one of them, to get the radius.
So what is the radius? I got how do you call it? R square is equal to 80. I did not make R the subject because in my formula I have R squared there. So there's no need making R the subject again. You are wasting your time. So in my formula, wherever I see R square, I substitute the 80. So what were you also doing?
Half of 80 is 40. Half of 80 is 40.
It will be 40.
Half of 80 is 40.
So that would be 40, yeah?
Yeah.
Yes.
So it was a computational error. It was just a computational error. Not a procedure.
So correct that. So we have half times the pi times what? Times the 80. Is that it?
Yes.
Okay. So the 2 will go into 80. How many times 40? So that will give us 40 pi. Okay. So correct that.
Okay. Thank you, Doc.
Okay. Good. So that is the first approach. The second approach is where you take the point there to be the center. This first approach, that point I put there is not the center. It's by coincidence that it came out to be the center. Okay. Yeah. So the process is very important to me, and the final answer. Okay. Thank you. So the second approach we see here. Okay. So it means that the second approach you will correct that one. Instead of 40, we put 20. So correct that to 40. And now we okay. So we move on. Today we want to continue. We'll finish this slide, then we'll continue with another slide. We want to look at the cognitivist theories. We'll continue with that. That's a unit 3C. Today we will concentrate on Zotandines. Zotandines. Who has heard about this man before? Zotandines. Anybody who has heard about this man? To tell us a little about him. Zotandines. Adamu Musa, are you there? Adamu Musa. Edwina. I'm still giving my marks here. You are building your assessment. If I see you in my class and I called your name and you did not respond, -2. It means that you are fooling me. -2. Okay. What in Samuel?
Yeah, Doctor, please, I'm here.
Yeah.
I'm here.
Can you tell us anything about this man? If you don't have any idea, tell us no idea. I'll move on. Yes. Gifty, Obi.
Okay, so what I've heard about him is that he designed the base arithmetic blocks.
Good. You know about him. Yes. Thank you very much. He developed that material called multi-base arithmetic block. Thank you very much, Gifty, for two marks. Yes. Let's see another person. Abdullah Kwame. Abdullah. Is it there? -2. Okay. Agosa Christian.
Yes, please, I'm here. Okay.
That Agosa.
As she also has some 6 stages theory of learning mathematics.
Okay.
And a free play.
6-page theory.
A free play, and then also games 1, and then they had a structured play.
Okay. So good. You also know about these. Thank you very much. You know about these. Yes. And then Chumasi, Cassandra.
Sir.
Chumasi. Anything about this man?
Sir, he also propounded some 4 principles of learning.
Principles, yes. Okay.
Yes.
Okay, good. You
We
also
have the
know.
dynamic.
Good, good. What is the dynamic principle? Those are the things that I want to look at today. What is it? What is it about? Daniel. Daniel. Is Daniel there? -2 from Daniel. Dorcas.
Some there. Some there.
Dorcas.
Some there.
Yes. Can you tell us anything about these? Zoltan
But so about he designed the principles of learning mathematics.
Okay.
We have the dynamic constructivity.
So what is the dynamic about? Can you tell us about that principle?
So it's about learning through varied experiences.
Okay. Okay.
And that's what I can say.
That's what. Okay. Thank you very much. I think you are all saying the right thing. Yeah. So let's move on. Zoltandins. Can you see my screen? Zoltandins. Yes.
Yes.
Zoltandins is a mathematician at the same time a psychologist whose focus is on how children learn mathematical concepts through play, exploration, and concrete experience. Okay. He believed that mathematics learning should progress always from what? Concrete stage to abstract. Anytime you are teaching mathematics, you must always start with what? Concrete and end with abstract. That is what he believes in. That if you want to do any meaningful teaching, then proceed from what? Concrete to abstract. Concrete to abstract. How the children learn concept. So he's saying that for the children to learn concept meaningfully, you must give them some materials to manipulate. Okay, give them some materials. Start with the concrete. Okay, bring some manipulations, bring some concrete materials, and then you now move in that complexity till you get to the abstract. Don't just go and start with the abstract, especially those of us teaching at the secondary school. We think that at secondary school, you don't need concrete materials. They need them. They need them. Any topic you want to teach, make sure that you start from concrete to abstract. Okay, concrete to abstract. The concrete could also mean things that they already know, things that they have, things in their environment. You begin with that. Okay, use that one as a foundation. Give them the opportunity to play with those materials or the activities, and then you now zoom into your abstract teaching. Okay, so that is what Zoltandins believe. Do you also believe, or do you also agree with Zoltandins that meaningful learning should always start with your concrete materials, or should start from concrete to abstract? Any objection? You must use variety of materials, use variety of ways, and then give the children the opportunity. Let's be flexible, the opportunity to explore. Do you agree with Deans? Maybe there's someone who you may disagree.
Yes, we agree.
Yes. Don't always agree.
Yes, we agree. Yes, we agree.
Or sometimes looking at the maturity level of your student, you can go straight to abstract.
You can agree with him, but to some extent, disagreement.
Yes, I want that extent. I want you to explain.
Yeah.
Where your
for example,
comes
teaching geography about the aircraft, you've not been under the earth. So how do you maybe expose students to what is happening under the earth?
Okay, so when I come to your class and I'm teaching you what longitudes and latitudes are, okay, and I tell you the longitudes are the vertical lines, the latitudes are the horizontal lines, and all these lines are straight lines. Do you understand? They are all
imaginary lines.
They are imaginary lines. Okay,
yes.
So now when you go on the internet, the professors are saying that a triangle can include 2 right angles. Do you agree? A triangle. Do you know a triangle?
Yeah.
They are saying that in a triangle, when you take a triangle, you can get 2 angles which are 90 degrees each. You can get 90 degrees here. You can get 90 degrees here. They are saying you can get a triangle like that. Do you agree?
I disagree.
Because your teacher who taught you geography used abstract way, you did not use concrete materials. You did not use the concrete approach. And that's why you will not believe. Because if the teacher
having 290 degrees.
So look at the geography. We are saying this is the Earth. You are teaching the globe. You have brought the geography, so I'm bringing this for you to understand why you have to start concrete. If you have sent the globe, to the classroom to teach that day, The globe is a material, it's a concrete material. Send the globe, you are teaching the F. And then you tell them that all the lines are imaginary lines. Okay, so you have the longitude. Have you seen it there? Longitude. It's a straight line. It's not a curved line. You have another longitude there. It's also a straight line. It's not never a curved line. And then you have another one, horizontal. That's a latitude. It's also a straight line. If you draw two straight lines, don't they meet at the 90 degrees? So these two straight lines, 90 degrees, here to 90 degrees. Is this not forming a triangle? So can you see that a triangle can enclose two right angles? Okay. So teach always start with concrete materials. So that is how they were proving that. Okay, it's concrete. Send the globe to the classroom. Let them experience it. Let them see how the F look like. I don't want to send it to Euclidean geometry, but I'm trying to prove that anytime you want to teach, start from concrete material. Yes, any question?
So, sir, if the triangle has 290 degrees at its angle, then what will be the angle at the top?
Because you know that the total sum of angles in the triangle is 180. And so this one defy that rule. Yes, this one will defy that rule. What it means is that the total sum will be more than 180. But I'm saying that we don't want to go into Euclidean geometry. We don't want to go into Euclidean geometry. I'm only trying to tell you that anytime you want to teach, start with concrete. Let them understand it. Let them get a concept well. Okay. Okay. Any other question? Any other question? Yeah.
So please, the lines that you drew on the globe, are they straight lines or they are curved? Since the Earth is
they are all straight lines. Any geography student here, the lines on the globe, are they straight or curved lines?
They are straight, sir.
They are straight lines. Me, I'm a science student too. I'm not a geography student, but a little I know about geography, all the lines are straight lines. So if you have a longitude which is straight, you have a latitude which is also straight, they will meet at 90. They are all straight lines, those imaginary lines.
Then does it dispute the fact that the Earth is a spherical in shape? Because if it is spherical in shape, does it dispute the fact that the Earth is spherical in shape?
No, it doesn't. It doesn't.
If it is spherical in shape, how can we have straight lines as latitude and longitude?
Oh, so you think that they are curved?
That is my thinking.
The geography students here, we are not doing geography. Can we talk? He's saying that then it means that the Earth is not a sphere. The geography students. They are all straight.
Please, they are all curved lines. With the exception of the latitude 0 degrees.
I see.
Which is a straight line.
Okay, the rest are all curved lines. Okay, so maybe you have to go and do more geography. Okay. So that's it. So I think we must all embrace this belief that anytime we want to teach, we must start from concrete to abstract. Okay, concrete to abstract. So according to Deans, he said that you should always help the children to internalize whatever they are learning. Okay, we must try to build in some intrinsic motivation. It must be intrinsic. Okay, learning mathematics must be intrinsic. So he's saying that try to integrate into the personality of the student. Integrate the mathematics. Make sure that you present the mathematics to them so that they will develop that intrinsic motivation. They want to do the maths. Okay, and how will you do that? You know, children like playing. And so you have to start like playing. Put the mathematics, hide the concept in the play. Let them play first. Then from there, you now progress to maybe a semi-structured form, and then you can now zoom into your abstract. Okay, so don't just start straight with the abstract teaching, but make sure that you help the children to develop that inward interest. Okay, that intrinsic motivation must be there. I hope it's clear. I don't know how many of us do that. You think that you are wasting their time. You are not wasting their time. Once they develop interest in it through the play, okay, they will be ready to learn even the abstract one that you want to teach them. Okay. And so he's saying that in teaching a concept, you always have to put them into two, the primary and then the secondary play. the play that he's talking about, that put the hide the concept in a play. He said this play you must divide it into two: the primary play, and then we have the secondary play. Which one is the primary play? The primary play is the activity or the materials which is aimed at what? Helping them develop what? Interest in that concept. Okay, so it's any activity with materials aimed at gratifying immediate desire. So you want to develop their interest. And this involves manipulation. They will have to handle the materials, manipulate them, investigate, observe the materials, and so on and so forth. And then after that, you come to the secondary play. You see, this one too is calling it a play. Secondary play. And this secondary play, you now structure it in such a way that by the time they will finish playing, you have achieved your goal or your objective. So this one is not just the free type, but it is structured. So they'll follow it, and then they'll come out with whatever you want them to learn. So, and that involves building. It's a building with the materials. So the materials you have given them, they build it, then they start discovering patterns, and then from there, they form the concept. They form the concept. Okay, so he's saying that that is how learning should be. The learning of mathematics should be. Do we all do that? Do we give them this primary play? Do we take them to the secondary play? They are all play, but they will learn the mathematics from it. They'll learn the mathematics. Okay, so this came up with some principles. Yes, somebody mentioned 5, but I have put them into and mentioned 4, but I have brought 5 here. We have the dynamic principle, we have the multiple embodiment principle, perceptual variability principle, mathematical variability principle, and then constructivity principle. So 5 principles. Yes, we want to see how we can use these 5 principles in our teaching of mathematics. 5 different principles and teaching mathematics according to Deans. Yeah, so when we take the dynamic principle, anybody will tell us what Dean said about that? These are the principles that every teacher should know. Every teacher should know. So if you don't know this, when you are teaching the concept that your student will not understand. Yeah, so let's start with Nashiru.
Yeah, the dynamic principle had to do with a teacher. You need to be flexible. You don't need to be static at one, like holding to one method of teaching. You need to be flexible.
I want to understand your flexibility. It means that you use variety of methods, variety of strategies. Okay. Okay. That's good. That's good, Nashiru. Yes, any other? Dominic, Aka. Or Kwaku Wama.
Sure.
Kwaku Wama.
So, well, when you are presenting, you must let the learning environment be resourceful.
What does it mean?
So, all the necessary equipment needed for the delivery of the lesson must be available, so that the student can be able to maybe develop their own learning.
Okay. The principles are many, so you have to be careful. You are not explaining different principles. It's a dynamic principle. What is it? Dynamic principle. Kwaku, have you talked already? So you can lower your hand. Kwaku Bama. The next person, Agosa Christian. Okay, -2 for Christian. Emmanuel Nketia.
Hello, sir.
Yes,
So with the dynamic, I believe the teacher should use different approaches. So let's say, since he's more centered in using play in teaching, let's say if we're teaching about numbers, let's say for the multi-base, if the children should play with that.
We are talking about dynamic principle.
Yes, sir.
What is that principle about, and how do you use it in your teaching?
So with the dynamic, I think the teacher should be using different approaches in teaching. So trying this and that, so that the learners will get to pick one with this.
Okay, that's fine. Hamidou Malik.
Yes, sir.
Yeah.
I think it's about using concrete materials for students who have a feel of it and use it to master many mathematical concepts. in order for them to transfer the knowledge from concrete to abstract.
Okay. Okay, it's all about using concrete materials, but the dynamic principle, what is unique about that? Kwaku nyame. Hey, kwaku nyame is not a -2. Jacob, answer. Jacob, answer. Jacob, yes. The dynamic
yes,
principle.
yes, sir.
Yes, what is that about? Joseph, go ahead. Is Joseph talking? Jacob.
The principle has to do with taking them through approaches. Yes, I'm talking.
Jacob, we can't hear anything. Okay, so Yakubu, come on.
Yes, sir. So the dynamic principle is using different methods so that the students can understand what you are teaching.
Okay. So when you explain that, you give me specific examples. Okay, what you have been doing. Okay, this is why, for example, you are teaching this, do that. Okay, Docas, what in?
For example, when you are teaching fractions, you let the children or the students start or force first to explore part of a whole.
Okay.
Because we know that fraction is a part of it. Then they will play games involving sharing the object.
Okay.
Then after that, you introduce the topic to them.
Okay. That's good. Lily, Anaba. Lily. Okay. Then the last person, Abdullah Kwame. Hey, please, if you are not talking, mute your mic. Mute your mic, Suleiman. Suleiman and Mohammed. Okay. So now let's continue. So let's take them one by one. After this, I'll ask about the other one. So the dynamic principle. So look at the meaning I have there. It says children learn mathematical ideas best when they are allowed to explore and experiment freely before being introduced to what? Formal rules or symbols. In other words, learning should move from free play, structured play, and then abstract thinking. So when you say dynamic, flexibility. Okay, flexibility. So for example, before teaching the concept of area, okay, the teacher will let the children arrange. Okay, arrange. You want to teach them area. So most of us have taught this concept, area, but our children don't really know what area is. They don't know. Okay, so if you want them to find the area of the surface of the table, give them some small squares, and then let them play, let them arrange it on the table, and let's see how many will cover the surface of the table. You see, they play. Then now you now zoom into your what? Your area. Okay. So they don't know that the number of squares that will cover the surface of the table is the area of the surface. They don't know. You only go and tell them that the area of the surface is length times breadth. No, let them come out with that length times breadth. Okay, so teach them the concept. Let them understand. So you are saying that before teaching the concept of the area, you let them play, okay, with what? Squares, small squares, arrange them to cover the surface that you want them to find. Then after the exploration, the teacher guides them. You now guide them to see by counting the tiles or the squares to see how many will cover the surface. Okay, so this movement from the exploration to the structured understanding reflects what we deans refer to as dynamic principle. Do we use that when we are teaching, or we just go straight the area of a rectangle, length times breadth? Do we go that way? Do we do that?
Yes, sir.
Yes.
So what is the area of a triangle? The area of a triangle is what? What's the area of a triangle?
Length times
breadth.
That is what? The area of a triangle is what?
Half base times
Base times
Height.
height.
Yes, sir.
Half base times height.
Yes, sir.
Half base times height. Do plane figures have height? Do you know what height is? When you have a table, the height of the table, you can get it. You have a box, you can get the height of a box. Do plane figures have height? I want you to tell me. Do plane figures have height?
No,
No.
sir.
No.
So why are you confusing your students? Do they have height?
No.
Yes. So if I have a box, this is my box. Yes. This one will be the height of the box. The height. So because it's a solid, I have the box. If I have triangular prism or pyramid, I can get a height. But then if I have a triangle, where is the height? Which one are you calling the height? You see, so we are confusing them. But if you unfold it, you want to find the area. First, you start with the triangle, rectangle. They have found it, and then they say that for the rectangle, it is length times breadth. Length times breadth. Then you cannot ask them to divide the rectangle into two. Oh, who is that? You see, maybe next time they have to give me the opportunity to remove people from my classroom. Okay, so now they know that the area of a rectangle is length times breadth. So when you divide a rectangle into two, one of them will be a triangle. So what will be the area of the triangle? So area of a rectangle is length times breadth. So now the area of the triangle will now be what? Length times breadth divided by 2. Yes, so that will be the area of a triangle. The length by breadth divided by 2. Is that okay? Then when you go ahead, they proceed, then they will now know that, okay, this length can also be called the height. But the plane figures do not have height. Do not have height. Maybe what we are referring to is the altitude. Okay. So make sure that you help them to understand the concept very well. Okay, understand the concept. Any question on this dynamic principle? So anytime you are teaching, make sure that you use the dynamic principle, okay, which calls for what? Flexibility, moving from free play, structured play, and then the abstract thinking. So you first of all give them the materials, let them explore in free state, and then they will now, observe the patterns and then come out with that. Okay. So with that one, Deans is what? Proposing 3 stages. He has a number of stages, about 6 stages, but when you look at it holistically, he is proposing 3 stages. The first stage is the preliminary play stage, and then we have the more structured one, and then we come to the mathematical concept that you want to communicate to them. So that is what he is proposing, that if you want to teach any concept, it must go through these 3 main stages. Okay, we will look at his 6 stages later. Must go through this. So preliminary play stage, where you put the thing, that one is unstructured, give it to them to play with it, and then you come to a more appropriate structured activity, and then from there you have the concept now emerging. Okay, and so that is what he is proposing. Okay, so I think I've explained this one already, the preliminary, and then a more appropriate structured, and then we now come to the where the mathematical concept is taught or may emerge. Okay, any question before I go to the next one? Okay, the next one is the multiple embodiment principle. Yeah, before I go there, let me ask some people to tell us about that one. Multiple embodiment principle. What does it say? We have seen the dynamic principle, where we have to be flexible. Okay, flexible in our teaching. Now, the multiple embodiment principle. What does it talk about? Multiple embodiment principle. What does it talk about, and how do we use it in our teaching? Jacob, answer. Jacob, answer.
Thank you, sir. The multiple embodiment principle talks about the fact that each mathematical concept should be taught using as many examples and situations as possible.
As possible, okay. Oh, yeah, I think I've told you what to do, how to answer my questions. You say, then you give me specific examples, like how we'll be using it in the classroom. Okay, Lilianaba.
I'll come back later.
Lilianaba. Lily. Lily is -2. Jacob, Jacob, as you can lower your hand now. Muniru, Mubarak. Or Mubarak.
Yes, sir.
Yeah, Muniru, yes. What do you know about this principle?
So this principle says that learning is more effective when students connect new ideas through different representations and experience.
Okay.
For example, I want to teach fractions and I come inside with oranges and cut it into either halves so that they themselves can also do and see. So with that, their understanding would deepen and their interest in the learning will be more. Through that way, effective learning can take place.
Okay, so you are teaching, you say when you are teaching what? Come again, the example.
Example fractions, then I come with oranges to show how to divide them into the halves to show either 1/4 or 1/2.
Okay, that's a multiple embodiment.
Yes, sir.
Okay, that's okay. Then Daniel. Daniel.
Please,
multiple embodiment principle. What is it about?
Sir, it's about when you want a child to understand a concept, you need to give several examples so that the child will get the concept. For example, to let a child know the understanding of two-ness. So you bring 2 tables.
Okay.
Then you bring 2 human beings. You use different items as an example so that the child will know the two-ness in the object.
So in mathematics, how do you call that? You bring the 2 tables, 2 pens, 2 markers, 2 dusters. So the child is trying to get that two-ness. What in mathematics, what time do we give to that? What is the child doing?
Abstracting.
Abstracting. Thank you very much for 2 points. I'll give you 2 marks. Yeah, that's good. That's good. How about you? How about you, Robert? What do you know about the multiple embodiment principle? Dominic Aka, can you mute your mic? Dominic Aka. Ababio. Is Ababio there? -2. Ababio.
Sir.
Yes, Ababio, huh?
Oh, sir.
Yes, go ahead.
Sir, it's about a lot of examples being given to the students.
Okay.
Okay.
A lot of examples. That's all.
Yeah, like it's a practical example. Coming to class with a toys or playing game for them to be interactive with them.
So be careful. We say a lot of examples. A lot of you come and give irrelevant examples, unnecessary examples, or examples that will be testing the same thing. You are not talking about this principle.
Okay.
The same example. There must be something. What type of example? Is it about a lot example? Mariam.
Yes, sir.
Mariam.
Yes,
yes, multiple embodiment principle.
Please, the multiple embodiment principle talks about a teacher using different methods to teach his learners.
Okay.
For instance, when I'm teaching photosynthesis, for instance, I first bring a diagram to show the learners what chloroplast is.
Okay.
And then I will use real life examples to by bringing the learners outside, maybe in the garden, for them to know, for them to know how plants grow in the garden and the forest too.
Okay. You are a science teacher, so you are giving an example in science. Okay. That's fine. That's fine. So please, the principle, let us be careful. We don't miss them. Okay, so we have seen the dynamic principle. So let's see the multiple embodiment principle. So here, you're saying that the mathematical idea should be represented in several different, the one who say a lot of examples. You can say different examples, not a lot, not just a lot, but several different. Okay.
Okay, sir.
Different example in different context. Okay, in context. So be careful there. Mathematical ideas should be represented in several different contexts or embodiments. For example, such as manipulatives. You see, you bring manipulatives, you can bring diagrams, you can bring symbols. That concept should be experienced in different what contexts. And this will strengthen the what conceptual understanding of whatever you are teaching. And to connect the concrete to the abstract. Connect the concrete to the abstract. Okay, so for example, the one who gives the example, please, if you are not taking, mute your mic. So the concept of fractions can be taught when you want to teach the concept of fraction. You can teach it using paper folding. You can teach it using fraction strips or fraction grid. You can also teach it using what? Maybe a pizza or some object cut into pieces. Okay, so you see the same fraction you are teaching using different what? Representations. Different representation, different context. That's the multiple embodiment principle. And when you do this, so who is just opening the Micah?
Hello, sir.
Francis, mute your mic.
Sir, please, we cannot hear you.
Hello, can you hear me?
Yes, sir.
Yes, we can now hear.
Yes, we can hear.
Okay. So we are saying that the multiple embodiment principle is about. Please mute your mic. Those who are putting on their mic, they are disturbing me. So the multiple embodiment principle is all about presenting several different in context, okay, or representing the context, the concept you are teaching in several different contexts. That's the multiple embodiment. So we have given an example that you are teaching a concept of fraction. So when you are teaching a concept of fraction, you can use paper folding, you can use fraction grid or strips, you can use other objects and divide them into pieces. So you see, the same fraction you are teaching, but different contexts. Then they will understand what a fraction is. When they form this, okay, they will not forget it. So that is how we use the multiple embodiment principle. Several different contexts, presenting the concept in several different contexts. Don't use just one approach. You don't use only paper folding. Someone will come the whole day is teaching fraction using paper folding. No. You can use paper folding, you can use a fraction chart, you can use other things, okay, so that they see it in different contexts. Bring in some materials and also divide for them to see how the fraction is taken out of the whole and so on and so forth. And this will help the children to form a strong concept or foundation. Yeah, so that is the multiple embodiment principle. So, and this is the one behind this multiple embodiment principle. And as a result, he came out with a material. I think our friend mentioned it, the multi-base arithmetic block. He came out with a material that we can use when you are teaching. Okay, when we are teaching. And that is the multi-base arithmetic block. I don't know how many of us have seen the multi-base arithmetic block before. How many of us have seen it before? Yeah, so if you have not seen it before, I have some here. We have the unit, we have the long, we have the flat, we have the block. This is the multi-base material. When you go read about this multi-base material and see what this material can be used for, very, very useful material that can be used to teach a number of concepts in mathematics. And it is Beans who is behind this. He brought out this material because he advocates for what? Teaching through concrete to abstract. And so if you are saying they should teach from concrete to abstract, you need to demonstrate. And that is why he demonstrated using his multi-base arithmetic block. So please, let's read on this multi-base arithmetic block. Okay. Any question? Any question? Any question? Please, can you hear me?
Yes, sir.
So we can.
Yes.
Now let's go to which is the perceptual variability principle. Perceptual variability principle. Does anybody tell us about perceptual variability principle?
Doc, I want to ask a question.
Yeah, okay, go ahead.
Please, based on the multi-base arithmetic block.
Yeah.
I don't understand why when you get to class 3, the unit differ from class 4 up to JHS 3.
What differ?
The unit. You see, class 3, they will tell that a unit is 10. But when you move to class 4, they will say a unit is 100. Now, when you come to
10. Well,
yes,
I don't understand. How can you
represent
be 10 and unit?
Based on the multi-base block? The long for the unit, you go to the long, and in class 3, they will tell that the unit represents 10 units. But when you move to class 4, the same unit they will say it represents 100. When you come to junior high,
block. Okay, I'm not aware of what you are saying. Multi-base block, or they are using their own material.
That's what they have been giving us in the bush. So
yes, that is multi-base block. They say multi-base block.
Yes.
Or they are using some material to represent a
the
different
multi-base block. The multi-base
block. Yes, unit is 1. One is unit.
1.
Yes.
When you get to class 3, they say unit is 10.
Hello.
Yeah, sir. I want to clarify something. In some books, they use the unit as cube, and the long as long and flat the same. But as for the small one, no, they represent the unit as cube. So as the child move forward, they increase the cube.
Yeah.
So maybe class 1 they will use the cube as 10. When they reach class 6, maybe cube will represent 100, and when they reach JHS, they will use
this
the cube to represent
material.
100.
Yeah, this is somebody's material. This multi-base block. He's saying that the first one is the unit. We have the long, we have the flat. Depending on this concept you want to teach it with. So look at the concept. Don't look at the matter, but look at the concept they are teaching. Sometimes they are teaching place value. So if you are teaching place value, they will use it to represent the places of the numbers. Yes. If you are using to teach number basis, then you will go accordingly. So look at the concept they are teaching the material with.
Okay, Doc.
Okay.
Yes,
but as I said, this concept, we develop them progressively. Last time I was telling you, we develop them progressively. You have a square. You don't teach those geometric figures with the properties at the lower primary. Okay, so the child can see any four-sided figure, he say this is a square. But when he gets to class 4, class 5, he must differentiate between a square and a rectangle. After class 1, you got class 2, he can say that this is a square. But he doesn't know the difference between a square and a rectangle. But we are now developing. So progressively, then the child will move there. Yes, Adamu, Musa.
I just wanted to clarify the question my brother was asking.
Yeah, okay.
For the unit, then it is representing numbers with the Danes block, and we are using it as a counters. So if let's say primary 1, they are telling you the units represent 100. You are just telling the child that the long is 10, is made up of 10 of the units. So the child will just do the multiplication. So that the concept is we are using the material to represent values of numbers. So as we move from classes to classes, we only change the value of the unit. So let's say JHS like this, the JHS1, the unit is represented. The value of the unit at JHS1 is 100,000. Yes, 100,000. So you ask the child. Then we have 10 of the units in the long. So what will be the long? Then they will just do the multiplication and tell you the value. So then we are using the material to represent values of numbers. That is the concept.
So it is not that we are changing the unit to a different thing.
Yes, sir.
The unit is unit. Long is long.
Yes.
And we have 10 units in the long. We have 10 longs in the flat. We have 10 this in the, and so on. Okay. Yes, any other question? Yes, we will ask about the perceptual variability principle. What is it also about? We have seen the dynamic principle, multiple embodiment principle. Now, what about the perceptual variability? What does it mean? Doctors?
Please, it's about mathematical concept being represented using different physical forms and appearances to students to recognize the concept that you are teaching.
Good.
Example, when you are teaching place value, you can use bundle of sticks or base 10 blocks to, or abacus beads to represent the tens and ones. For them to get the concept.
Okay. That's the perceptual variability?
Yes,
so
sir.
Where is the variability there? I want to get you clear. That example you have given.
About the tens and the teaching place value.
Where is that this principle coming in?
The idea of the tens and ones make 10 ones make 10.
That's the variability, perceptual variability. There's some variability there, perceptual variability. Okay, that's okay.
So then I have a question.
Christian. It's not responding. Kelvin.
Yes, sir.
Kelvin.
Yes. Yes, I'm here.
Go ahead. Go ahead.
Are you saying I should go ahead or you're talking to Kelvin?
Yes, go ahead.
Okay. And as my sister who said now.
Yeah, perceptual variability principle.
Yes, you use the multiple embodiment as a concrete of the perpetual variability. They are almost the same, but on this one, we go inside about how the
perceptual variability principle is the same as which one?
They are almost the same as the multiple embodiment.
Embodiment, okay.
Yeah, so you are saying the multiple embodiment is a concrete of the perceptual variability.
Okay, but you have not explained it well for me. Okay, so that's fine. Justina,
Sir.
So
to me, the ability to interpret a concept through variety of physical context. So, example, when you are teaching addition of numbers, you can present counters or let learners use their fingers to add numbers. Then maybe you can use money. Kofi has 2 CDs. Ama having 4 CDs. When they put it together, how many are they having? So that's what I understand.
Okay. That perceptual variability.
So please, I have a question.
Yeah, go ahead.
Please, per the explanation we are giving for the perceptual variability, I think it's almost the same as the multiple embodiment, because with this we are using different representations to expand the learner's knowledge.
Who is giving you the perceptual variability? Have you given your explanation? What is it? The perceptual variability.
Okay, so
what
I'm not trying to get the difference, but the explanation we are giving, like that, as she said, when you are teaching this, use sticks later you use for the count, you use money, later you use this sticks or something. So I think we are using different representations.
So to you, what is the perceptual variability? What's it about?
So I was thinking it was almost the same as the multiple embodiment.
The multiple embodiment talks about what? Okay, let's see. What does it talk about? The multiple embodiment.
So we said with the multiple embodiment, we are using various representation, like different materials to represent the same concept, so that
in different contexts
will get it. So.
In different contexts.
Yes, sir. Context, yes, sir.
Different context. And then we are saying that the perceptual variability too is about what? That one we have not settled yet. You are giving me what you know about perceptual variability.
So per the explanation they gave, I was thinking it was almost the same as the multiple, but so I'm not trying to get what the perceptual.
So they are giving there, so give yours. Why are you judging what they are giving?
I'm thinking it's also the same as the embodiment, because with this too, we also use multiple physical contexts. We use different materials to teach the same context.
Okay. So now let's look at what the. Come in. Yes.
Okay, so I also want to help him.
Okay.
For the difference. So you say that the multiple embodiment is a practical teaching strategy that we use, but the perceptual variability is the theory and the justify why that strategy should work.
Hello, sir.
Hello. Yeah.
So this is Alfred.
Yeah, go ahead.
So looking at looking at the perceptual variability principle, we are saying that this one suggests that students learn more effectively when exposed to different forms or representations of the same mathematical idea.
Yeah. Which one is that?
That's a perceptual variability principle.
Okay, so give an example.
For example, when we are talking about using various materials such as diagrams, symbols to convey a concept. If we are teaching multiple representations, it means that we are supposed to use different diagrams and symbols to convey a concept that has to do with the same mathematical idea.
Okay.
For example, if we are teaching red, the color red, then we bring what's the name? A square. We paint a square as red. Then when a child sees red using the square without showing him a triangle that is of red, or a rectangle that is of red, it means that the child will only see square as a red. So we need to introduce the child the triangle, which also painted red, the rectangle, which also painted red, so that you see that the color red talks about all just the color and not the triangle or the shape of that particular object.
Yeah, good. So you see, you want to say is the same as the multiple embodiment. Okay, so let's go on. Yes, can you see my screen? Please, can you see my screen?
Yes, sir.
Okay, so I'm moving to the perceptual variability principle. Look at the perceptual variability principle. Is a concept or a concept should be presented through different perceptual forms. Perception, different forms. It can be in terms of color, as my friend has just explained, the sizes, the materials, the position, and so on, which is different from the multiple embodiment we are talking about. Even the same concept, but maybe the color, the size, the material, the position, and so on, the orientation, so that the learners don't tie it to the specific thing that you want to teach. They don't tie the color to triangle. You are teaching a triangle, and every example that you bring to the class is a red triangle, red triangle, red triangle. So when they see blue triangle, they will not know that it's a triangle. They will tell you that that triangle is a rectangle. So we are saying that perceptual variability principle, okay, different perceptions or perceptual forms. And I've given an example of that, the color, the size, the material, and so on. So for example, you want to teach the concept of set. So the teacher will use what? Buttons, fruits, shapes, pictures, and so on. I was surprised when the BEC student some years back, Waik asked a question drawing the right angle triangle like this, and most of them didn't know that this is a right angle triangle. They didn't know because of the perceptual variability principle. The teacher always draws the triangle, the right angle triangle like this. So the 90 degrees is always sitting flat. So when they turn the 90 degrees to the top, they didn't know that it was a right angle triangle. That's what we are saying here. Okay, the size, the position, and so on and so forth. So you are teaching a rectangle, don't just teach it with one size dimension. You can increase the dimension and so on and so forth. Okay. So you are teaching the concept of set. So we are using all these things here. So each time grouping them. So they group them, maybe group of, how do you call it? Oranges, group of tables, group of this. So not just the appearance. So at the point, the children will develop the concept of what? Of sets. They know that it is about the set, the collection of objects, the collection of this. I don't know whether you are getting this principle clear. The perceptual variability from the multiple embodiment. So the orientation counts here. The size counts here. Don't always use the same size. Vary the sizes. The material that you use counts here. Don't always use paper. Sometimes use plastic. Use metal. Use wood. So that they will not associate the paper to the concept. I hope we are okay.
Yes,
so
sir.
Perceptual variability principle. They have some resemblance with the embodiment, but it's not the same as the multiple embodiment principle. No, it's not the same. Okay. Any question on that? Any question on that? So the principle suggests that conceptual learning is maximized when children are exposed to concept through variety of physical context or embodiment. Okay. The experiences provided should differ in outward appearance, the appearance. Okay, very important. The appearance should not always be the same size, should not always be the same orientation, should not be the same length, should not be the same height. Okay, then we are talking about the perceptual variability principle. So when you arrange for them to abstract the commonalities, then we have that principle come in. Yes. Any question before I move to the mathematical variability principle? I'm sure somebody will also say the mathematical variability principle is the same as perceptual variability principle. Any question? Yes, somebody is raising her hand. Can you go ahead? Yes, go ahead. Who is raising? The person has lowered their hand again. Okay. Any question? Somebody that's raising. Muniru.
Okay, so if I am also explaining the same concept in different ways, can I classify that as under perceptual variability principle?
So give us example. Give us example. The way you have said, I don't understand. Give us
example. I am to explain integers to my
all of us listen. Yes.
So, and I said integers refers to both positive and negative numbers. Hello, sir.
Hello. Yeah, go ahead. You say you are doing
what? So maybe that is one way.
What? You have not seen that way. One way. What is that one way? Come again. Say you are teaching what concept?
So I say like you want to explain integers.
Integers, yes.
Then you explain the definition in different ways.
Oh, that is definition. So you are not teaching.
Oh, okay.
You're just giving definition.
So we count
that will soon come in. So most of us teach mathematics with definition. Never start a mathematical concept with a definition. You confuse your student. We will see some of these things later. Because the examples that you are giving or the definition you are giving is also another concept. Okay. Yes, Agosa.
Hello, sir.
Agosa, yeah, go ahead.
Yes, please. I am still not convinced between the differences between the multiple embodiment, and then the perceptual. Please, can you throw more? Can you give
anybody to help
differences?
Agosa? Anybody to help Agosa? Anybody to help Agosa?
Yeah, I want to come in.
Okay.
The principle of multiple embodiments. That one has to do with using a variety of, let's say, materials to teach the same concept.
Okay. So give the example so that you understand
like you were teaching the example you cited concerning teaching of fraction.
Okay.
I can use paper folding to explain fraction to my students. After that, I can also use, let's say, oranges to share to also explain fraction to my learners. So without changing, the idea is fraction. So let's say
that one talks about the context.
Yes.
So that one is talking about context. Please let's say no, that one is talking about context, the context in which you teach, the context. Can be a picture, can be diagram, can be that, and so on. Context.
Okay.
But when you come to the perceptual variability, it's talking about orientation. Orientation. There I talk about the size. Don't keep the same size. You are teaching the rectangle. Don't keep the same size. Don't keep the same color, and so on.
What I'm saying is that okay, let's take the fraction. Okay, let's take the fraction as a topic that we are teaching.
Okay.
Let's use the two to explain the fraction.
Okay.
That's what I'm trying to say.
Okay, so go ahead and explain what you understand.
So we are saying that the multiple base
embodiment. So we use the multiple embodiment.
Yes, multiple embodiment. We use the either you use a paper
folding,
paper folding, or the or you can still use a chart to teach. That one is a different method that you use to teach. Okay. Then the perceptual is that we are using different shapes.
You are not using different method. You are using different representation there. Different representation for the same concept. It's not method.
Okay.
Different representation.
Can I come in?
Yes,
for
come
example, let's say you are teaching maybe triangles, and you show children triangle, but you are using maybe a red colored triangle. So if you don't vary, maybe you are teaching still triangle, you can use a blue colored triangle. The idea is the size.
So this one that you are explaining, which principle is that?
No,
that triangle you are teaching is what?
The perceptual variability.
That's the perceptual variability.
I've used a red colored triangle to explain. I've also used blue. If I don't vary the colors and I limit it to one color, the child may think that every red colored material is a triangle. That is what the concept
so
is
you need
trying
to vary the perception there. So that they will not tie the triangle to the redness. And then when you come to the multiple embodiment, and what does it say there?
That one using a variety of, let's say, approaches to teach the same content.
Can you use different examples?
Yes, using different examples, like the paper folding to teach fraction, like using a pizza to teach fraction. So many things.
Don't change the topic. Don't change the topic. You also triangle. You've used the triangle, different colors to represent the perception. Let's come to the triangle. Let's use the multiple embodiment. That's what I'm trying to say. Don't go and use fraction for the multiple embodiment.
The idea is not the same, so you can't just limit.
I don't see it's a question.
Please, can I come in?
Agosa, that's what I'm saying. Agosa, the way you understand, bring it out. Let's correct you.
Please, can I come in?
Understand them? The principle.
Please, can I?
They are not the same thing. Yes, Daniel.
With the fractions, with the multi-base principles, that's what you said. You can use oranges. Okay. You can use blue. If I don't vary the colors and I limit it to one color, the child may think that every red colored material is a triangle. That is what the concept is trying to explain.
Okay.
You can use paper folding.
Board.
Yes,
board.
Yes, and with the perceptual principle, with same fraction, with the paper folding, you can change the colors of the papers so that whenever the child sees it, he knows that this is what it is in his perception.
So the perception, the thinking,
yes.
the thinking.
Yes,
so if that paper is big, now bring a small paper and also use it to divide.
Yes, sir.
If the paper that you were using there is red, now change it to a different color so that they will not associate that noise, that color, that size with the concept. Then we now come to the perceptual variability.
Okay.
They are not the same thing.
I'm now okay.
Are you sure you are okay?
Yes, please. Yes, please. I'm okay. Thank you, sir.
So, sir, from what we are saying about the perception, it's like we are trying to avoid something like this. For example, if you if you tell a child that, let's say, this picture is a goat, if you don't take care, every four-legged animal, the child is going to say this is a goat. But so we are trying to avoid that. Maybe even if it's a lion, the child is going to say it's a goat.
Yeah. I think I even give you a good example, the triangle that the YA gave, and the students say that it is not a right angle triangle. That's a good example for the perceptual, because teachers are always drawing the right angle triangle, said that the 90 degrees is always having a base, horizontal. So when you turn the triangle a bit, then they say that this is not a right angle triangle because of the orientation, perceptual variability there. This one is not about multiple embodiment. Perceptual variability has come in. They have associated that particular orientation with a right angle triangle. So when they see it in a different orientation, then they are out. Then they are out. Are you okay?
Yes.
I went to a school and then I gave them algebra. I gave them some questions to factorize for me. I gave them, let me put it there, for them to factorize. Can you see my screen?
Yes, please.
Where is this thing? I gave them this question. I gave them why. Can you see my screen? Yes, y square plus 4y plus 4 is equal to 0. Then I asked them to factorize this. Only a few of them were able to do it. Only a few of them were able to do it. Agosa, can you tell us why they were not able to do it?
Yes, because the teacher x.
Thank you. Because the teacher always teach the quadratic using x. So when they saw it giving y, they were confused. I even increased it. I went to m squared plus 4m plus 4. They should factorize. They couldn't do it because the teacher is always using s. That's what we are talking about here. Perceptual variability. Don't let them associate the s with quadratic equations. No. Why? What makes it quadratic? That is what you are teaching. That's the concept you are teaching. The degree of 2. The highest degree of 2. That's what makes it quadratic. It's not the variable you are using there. So please, let's get this thing clear. Okay. So you need to vary the perception here so that they will not see it and say that, no, this one is a how do you call it? It's a quadratic or it's not a quadratic. I hope it's clear now.
Yes. I'm okay with it.
Okay. Then we come to the mathematical variability principle. Yeah, then this one we will get more confused. Mathematical variability principle. To understand mathematical concept, learners must experience variation in the non-essential features of example, while critical features are maintained. The critical one, the important ones are maintained. This helps them identify what truly defines the concept. So while teaching the rectangles, okay, the teacher shows several rectangles of different lengths, width. So it's now coming to coincide with another one, orientation, and so on and so on. So the variation helps students to realize that, for example, right angle is what is making it what? The concept, the rectangle. The fact that it has a right angle, 90 degrees, that is what is making it a right angle. It's not because it is a four-sided figure, but because it has 90 degrees at the corners. So any quadrilateral in which you have 90 degrees at the corner is a right angle. It doesn't matter the size. It doesn't matter the size. Okay, so you have to help them to identify the non-essential features as well as what? The critical features. Please, when you sit down and then go through the principles and see. I know Akosa will say that this one too is the same as another one. Okay, they are alike. They are alike, but each you have to pick something small, little from there, and that helps the children to form solid foundation. They form the concept solid one. Okay. Any more questions? So these are the principles. Make sure you use them. Let us use them. We are not learning them for exams, but we want to learn them so that we can use them. Okay, because these things help our students to understand the concept we are teaching. Because we don't do that, they find it difficult to understand the concepts. So let's use the principles. That is somebody's principle. Yes, you may also come up with your own principle, what is working with for your students, but make sure you use this one as a foundation. Even if you have your own principle, okay, use this one as a foundation. Okay. Any questions? Any question? Okay. If no question, then we'll go on. Okay, so I think there are some examples here. Let's say vary the irrelevant attributes. When you are teaching the concept, you vary the irrelevant attributes. Those things that are not relevant, vary them. The size of the angles and so on and so forth. The length, the size, the position on the paper, while keeping the important ones, okay, constant. Don't vary them. Okay, and I've said that many of us believe that squares and rectangles are not parallelograms. Yes, so if you don't use this particular mathematical variability very well, your children will not know that squares and rectangles are also called parallelograms. They are all parallelograms. Every square is a parallelogram. Every rectangle is a parallelogram. If you don't teach this well, they wouldn't know. They wouldn't know. How many of us know that a rectangle is a parallelogram?
And you say, since it's having four sides, any four-sided figure is a parallelogram.
Any what?
Any four-sided figure is a parallelogram with the features of having a 90 degrees.
No. Any four-sided figure is not a parallelogram. No.
It's a quadrilateral.
Yes, a four-sided figure is a quadrilateral. Let's take a look.
So the parallelogram has to do with two sides being parallel.
The what?
The parallelogram has to do with two sides being parallel.
Yeah.
If you take rectangle, you will get two sides parallel. If you take rectangle, so it has to do with the sides being parallel.
Okay. Yes. Yes. Oh, somebody else wanted to ask a question. Oh, I thought
Gifty wanted to ask a question. Gifty wanted.
Gifty, yes. Oh, he's gone. Okay.
No, it wasn't a question. I wanted to add to what the man was saying.
Okay. Yes. So go ahead.
What I was saying is that parallelograms have two sides to be parallel. So when you take a set, you have two sides always being parallel. So a square is a parallelogram, a rectangle is a parallelogram. So you can't say all quadrilaterals are parallelograms.
No, it's not true. Not all quadrilaterals are parallelograms. A kite cannot be a parallelogram. No.
Yes.
Joshua, Lamke.
And please, if you say when you talk of a parallelogram, two sides should be parallel and
two opposite sides. Make sure you bring that opposite. Two opposite sides or two pairs of opposite sides.
Two sides being two opposite sides are parallel. That makes it a parallelogram.
That doesn't make the parallelogram, but two pairs of opposite sides. Two pairs. If you don't bring the pair there too, it's not a parallelogram.
If two sides are parallel, it doesn't make it a parallelogram. but it's not. Yeah.
I've mentioned a pair. Be careful. I said 2 pairs of opposite sides before you can say it's a parallelogram. Not 2 sides. 2 sides are parallel, cannot be a parallelogram. Is that okay?
Yes, please. So, sir,
yes.
Can I come in?
Yeah,
so
come in.
It means if one pair is parallel, it's not a parallelogram, but the opposite side should be pair. That makes it a parallelogram. Assuming maybe
the what? The what should be? The what? Come again.
I'm talking about the opposite side, 2 pairs of opposite sides.
Yes.
It means trapezium, for instance, when one pair is parallel, the other side is not parallel, so it's not a parallelogram. But the 2 opposite sides, this side which is opposite to this should be parallel, and the other side which is opposite to this should also be parallel. That makes it a parallelogram.
That makes it 2 pairs. That makes it 2 pairs. Yes.
Okay.
I think you will have problem with the quadrilaterals. Okay, so please, 2 minutes. I'm going to explain this. Once I'm explaining means that I'm going to assess you on that. 2 minutes. Can you see my screen?
Yes, sir.
Yes, sir, but nothing up.
So when you take any 4-sided figure, this, and then you can identify just one pair of opposite sides being parallel. This figure is called what?
Hello, sir. It's called trapezium.
Thank you. It's called trapezium. Thank you. This is called trapezium.
It's a trapezium.
Thank you. It's a trapezium. I hope it's clear. It's a trapezium. So you see, our students, when you go to the schools, you draw this for them. They will tell you this one is a trapezium. Yes, they will agree. But when you draw this one, they don't know that this one is a trapezium. They are all trapeziums. Once 2 pairs are parallel, this and this are parallel, it doesn't matter how the other one join. All of them are trapezium. Okay, so when you take any quadrilateral and you can identify just one pair of opposite sides being parallel, it's a trapezium. Is that clear?
Yes, sir.
Yes,
Okay.
sir.
Now, when you take any quadrilateral, please, I'm explaining. Pay attention. I say I'm using 2 minutes. After that, you can ask your question. If you take any quadrilateral, one pair of opposite sides, we are saying it's a trapezium. On the other hand, if you go to the other side, and the other side too are also parallel to each other, then this trapezium becomes what? A parallelogram. Please, let's take note of that. Can we still call this one trapezium?
No, sir.
Yes, we can still call it a trapezium, 100%. We can still call it a trapezium. It doesn't claim the name of a trapezium.
Okay.
Just that we are giving it a special name because it has 2 pairs of opposites at being parallel. We are giving a special name parallelogram. Please, it doesn't claim the name of trapezium. So every parallelogram is a trapezium, but not every trapezium can be a parallelogram. Please get it clear. Are we okay?
Yes, sir. Yes, sir.
Okay. Now, when you take your ruler, have you seen my diagram? When you take your ruler and then you measure all the lengths, and then all the lengths are the same. This quadrilateral has a special name. Can somebody tell us the special name?
Square.
No, it's not a square.
Rhombus.
It's never a square. That is a rhombus. That is a rhombus. Thank you very much. 100%. That's a rhombus. Please try to understand. All the sides are equal. It's a rhombus. It can never be a square. It's a rhombus.
Okay.
Okay. Now,
if all sides and angles are the same.
Yes. Let me clean the this thing. Oh, my thing is off. Okay. I wanted to clean something, but let me go again. I want you to get a relationship there. Clear. So let me draw it again. This one, trapezium. This, having another one. Yes, we have a parallelogram. Can you see my screen now?
Yes, sir.
Okay. Instead of measuring the size, we rather want to measure the angles. So we have measured the angles. All the angles are 90, 90, 90. What special name is given to this?
square.
No, it is not a square. The correct name is what?
It's a
Rectangle.
It's not a square.
Rectangle.
It's never a square. I'll give you 0 when you put it, we say it's a square. So any quadrilateral in which each angle is 90 degrees is a rectangle. I hope it's clear. Yes. So can we say that this thing that you see on my screen is also a trapezium?
Yes, sir.
Yes.
Yes, sir.
Yes, sir.
Yes. Can we say that what you see on my screen now is a parallelogram? It's also a parallelogram. Are you getting the point?
Yes, sir.
Yes, sir.
Okay. So any question now? I think I've explained it to you. Any question on these quadrilaterals? We are not teaching this geometry using the property, so the students have difficulty in this, and they translate this one to the circle theorem. You go around the schools and they tell you circle theorem is the most difficult topic because of these things I'm teaching right now. They don't understand these properties. So how would they how do you be okay with a circle theorem? No. Yeah. Any question? Any question? Yes, go ahead. Who has raised a hand? So we are all okay.
Please, sir,
Yeah.
I have a question.
Yeah, go ahead.
Please, I want to know the differences between a trapezium and a trapezoid. Do they have differences?
Oh, this
Trapezium
one,
and
sometimes
trapezoid.
you can find, you are not using the internet at all. You can use the internet here. Sometimes you go to the internet, they will tell you is a language, it's a semantic. Like British will use the trapezoid, others will use the trapezium. It's a matter of these kind of things, they are not mathematics. Find out and see. You have your phone there, Google it and see. Trapezoid. They will tell you they are the same. This one is used by these people, this one is used by this. Another thing they will tell you. So these are not questions. Okay. Yes, any other question? Any other question? Some will even say that even the trapezoid will be a plural. Instead of trapeziums, they will say trapezoid means plural. Rhombus. We write plenty, we say rhombuses. But you go there, they will tell you it's rhombi or rhombi. So check those things if you're listening. Any question again? Any question again? Okay. And then I've also explained to you about a circle. You have a circle, you have the center, you have a line drawn from one part of the circumference to another part. The name is what?
A chord.
You have another one drawn from one part to another part through the center. That name is what? Chord. Is it a chord?
Yes, it's a chord.
Yes, I think I've explained that. It's still a chord. It is still a chord, but because it's passing through the center, the mathematicians have given a special name as well. It does not claim the name of the diameter, please. Okay. So the longest chord in a circle is the diameter. Okay. Thank you very much. So now let's move on. Yes, so I think we are okay with this one, this mathematical variability principle. We are okay with that. Then we come to the last one, which is the constructivity principle. The constructivity principle. This principle is saying that learners construct their own understanding of mathematical concepts through active engagement and discovery, rather than being told directly. So they are saying that rather than you going to the class and tell them the formulas, let them experience, let them construct their own knowledge. And that's the constructivity principle here. The constructivity principle. So instead of you stating that the sum of the angles in a triangle is 180 degrees, you rather arrange for the student to encounter different how do you call it, activities that will lead them to this generalization. Don't go and tell them. Give them different activities that will help them to come out with the fact that the sum of the angles in a triangle is 180 degrees. Can anybody take us through any activity that will lead us to do? Any activity that will take the students through to come out with this generalization that the sum of the angle in the triangle is 180 degrees? Anyone? Sometimes we don't have the activity, so we find it difficult to use this principle. Yes, Francis.
Let me come in.
Okay.
For the people to know the sum of angles in a triangle is
180 degrees. Without you telling them, you want to give them an activities. Then after going through the activities, they come out that, hey, say, the sum of the angle in the triangle is 180 degrees. They will come and tell you. You don't tell them. Can you describe any activity like that? Anyone here? You see, because we don't have these skills, okay, we don't have this, so we find it difficult to also use this principle. So we are just learning the principle. I know most of you will not use them. You have to use them. They are good. That is why we are learning them. And when you use them, your children will form what? Solid foundation. Anybody to take us through? Wow.
Sir, please let me try.
Okay.
Okay, so when you have a triangle and we cut the triangles so that we'll be having all the triangles, and we place the angles or we arrange the angles, we can see that it will be arranged on a straight line.
So you are right, but you have to start by telling us the prerequisite. You see that every good teacher must build a concept on what the children already know. You did not tell us what the children know.
Sir, please, what I normally use
line that you are bringing here will be strange to somebody. So when you are starting, you have to make that point clear that you already know what is on a straight line.
Sir, please, can I continue?
Yes, continue.
So I normally use the protractor. When you look from the protractor, you can see that.
Start again. We want to start. We want you to tell us the activity.
So the activity is you take a triangle and you cut the triangles into three so that you'll be having all the three angles.
Okay. When I interjected, did you hear what I said?
Yes, sir.
Okay, so start again.
I want to help him.
Adam will help.
First, you need to establish that the children know that angles on a straight line is equal to 180. Before
Thank you very
proceed.
much. Thank you very much. 100%. Don't just go straight to the triangle. Adamu, the way you are talking, that is how you are going to do the teaching. You make sure you establish it. You make sure you find out. Understand that the children know that the sum of angle on a straight line is 180. Because everything you are going to do is, that is the foundation. So if you don't start with that point, you can build. You build on the sand. Okay. So can you continue? So they know that the sum of angle on a straight line is 180 degrees. Yes. So go ahead now.
Then the next thing you do is you ask the children to draw triangles, different triangles.
Oh, you are still going abstract. You are still going abstract. We are still talking about deans. So you are still going abstract. Don't let them draw.
Please.
What should they do? Instead of drawing, they should do what? They should cut out the papers. They should cut out the triangles from papers, from materials. They should cut out the triangle. So they cut out their own triangles, different sizes triangles. They cut it out, not drawing. So go ahead.
So they cut out different triangles. Then after that, you ask them to cut the various the three angles.
Thank you. So they cut the angles. You have scissors. They cut them. This one is A, this one is B, this one is C. They cut all the groups will cut their angles, all the triangles. They cut them. All the triangles they cut. Then what do they do with the cut out?
Then they will arrange the angles. They will arrange the angles. And they will realize that it is forming a straight line.
Thank you. They will realize that the cutout is forming a straight line.
Then they will conclude that the angles are equal to 180.
Thank you very much. Thank you very much. Please, is that okay? You see how we teach? So
can I come in?
Finding out what the children know, you fail. Anytime you are going to teach, ask yourself, what should they know before I teach this topic?
Prof,
What should my student know before I introduce this concept? Very, very important.
I have a question.
Yeah, go ahead and ask your question.
How does the cutout form a straight line? I don't get that part.
Oh, I thought you were looking at my screen.
When they are being arranged well on a straight line, you get
I thought
180.
you was looking at my screen. So this is the triangle. You've made them cut out the angles. They have cut them out. This is A, this is B, this is C. And then you ask them to arrange the cutout on the straight line. You see, they will arrange them. When they put them, you see that the A will be somewhere here. They will put the second one. You see that the B will come there. And then the C. By the time they finish arranging, you see that they will get them on a straight line. Exactly. The triangles.
Sir, can I come in?
Yes, come in.
Sir, I can also use different methods to allow my
just one approach. Yeah, different activities. Yes. So, but the person who asked the question, does you understand this one before we move to your approach?
Yes, now they are understood.
Okay, so this one you see they are playing. They arrange them. Let's see whether it falls on it. So they arrange, and then before then they know that the angle on the straight line is 180. So they will see that all the triangles form a straight line, and therefore the sum of angle in the triangle is 180 degrees. That's it. Yes, then the next person, go ahead. Your second activity.
Okay, sir. My second activity will be angle sum investigation.
Okay.
And materials I will need is cut out angles for my student, or I'll put them in groups, give them cut out and triangles.
Do they know anything? Is there any relevant previous knowledge?
Definitely.
Previous knowledge? Is there any foundation that they are going to build on? You need to tell us that foundation. What's the foundation?
Okay, sir. Before this, I will first take them through what an angle is. And an angle on a straight line, what obtuse or acute angles are.
Okay, so they know what angle on the straight line is.
Exactly.
Okay.
Then I will give them cut out triangles.
Cut out. Okay, so you have already cut out the triangles, so you give them the various cutouts. Yes.
Exactly. Provide them with protractors.
Protractors. Okay, good. So now protractors.
Guide them to measure. Then these triangles will be different, not the same.
Different sizes. Some big, some small, some And then the protractor, they will use it for what?
They will use it for measuring each angle in this triangle.
Good. So the first group will measure, this is angle A, this is angle B, this is angle C. Yes. Then
after them measuring these angles, I will now guide them to put these angles together.
Okay, so when they put them together, so the first group will put them together, then they get 180. The second group has also measured this, and then they put it together, they get 180. The third group has also measured it, they put them together, they get 180.
Exactly, sir. Then I will now ask them, what do you find after adding these angles in the
each group? What did you get? Yes.
Yes. Okay, sir. And this will be my method.
Then they will come out. They will now generalize that all the angles, when you cut all the three angles in the triangle and put them together, is 180 degrees. Thank you very much. So that is another activity. So you either go through the measurement or go through the cutout. Let them cut the angle out themselves and then arrange. Good. So these are the two activities. You can always rely on these to teach this angle sum property of triangles. Yes. Any other question? Any other question? So we must always use that. Okay. Must always do that. Let them construct their own knowledge. Okay. Let them construct it. Don't give it to them. They do it, and then they come out with their own something. Any other question? So we are saying when students observe that the three angles fit exactly on the straight line, then they have constructed their own knowledge that the sum of angle in a triangle is 180 degrees. So when the student observe that all the angles that they are measuring with the protractor sum up to 180 degrees, yes, they are coming out with it. That one is more lasting than you going to tell them that the sum of angle in a triangle is 180 degrees. Okay. Any other question? Any other question? Any other question? Okay, so when you go try and get an activity, I'm giving you this one as a homework. Try and get an activity that will take the children through to establish that the sum of the interior angle of any regular polygon is n minus 2 times 180. So keep this in your head. Any activity that you give to your students to go through and come out with this formula, without you telling them that the sum of angles is 180. Yes. Yes, somebody is okay.
Because you said it's an assignment, like I have an activity that I can do with the children.
No, yeah, so you keep it. It's a homework for you. Yes.
Okay.
It's a homework for yes. Don't tell us now. So you go and then do it. Let's see. And then the second activity I'll give is you take the children through an activity that will show that the angle, how do you call it? The length of an arc. The length of an arc, L, is equal to theta on 360 times pi r. Yes. Yes. So get an activity like that. You don't just go and tell them this. And then the area of a sector A is equal to theta on 360 times pi r squared. Yes. So please keep these ones. You are not showing them to me, but you make sure you can get activities that you take your children through to come out with these formulas. I'll ask you to give account of that. Thank you. Yes. Any other question?
Hello, sir. The one you just wrote is supposed to be 2 pi r, not pi r.
Okay. 2 pi r. Yes. That's the length of the arc. That's what I mentioned it. Length of the arc. Theta on 360 times 2 pi r. Okay. And the second one is the area. The area, which is also theta on 360 times pi r squared. Yes. I want you to get an activity. Don't just the formula, get an activity that will take your children through to come out with these formulas. So I've given you 3 formulas. Make sure you go through all. The first one is the n minus 2 times 180 degrees as the sum of the interior angle of a polygon. Okay. Any question?
Sir, please, I want you to state the question for the third one again. That one is the area of what, sir?
Yes, I've given the first one. I said the first one is the sum of angle in the triangle n minus 2 times 180 degrees. The second one that I give is the length of an arc. The length of an arc, which is theta on 360 times 2 pi r. And then the third one is the area of a sector, which is also theta on 360 times pi r squared. So there are 3. These are all formulas that our students are memorizing. We don't have to memorize it. They need to understand it. They need to come out with the formulas themselves. So I want you to look for activities that you take your student through step by step to come out with these formulas. Okay. Is that okay? Can I clean it now? All right. Okay, so here where the constructivity principle is saying that we have 2 kinds of thinkers. We have the constructive thinkers and analytic thinkers. Always know that we have these type of thinkers in your class. Okay, we have these type of thinkers in your class. We have people who are constructive thinkers. We have people who are analytic thinkers. Okay, and then you will be able to prepare for them. So the constructivity principle states that construction should always precede analysis. Okay. This one always precedes. So you don't just start with the analytic one. Don't just start with the abstract one. Know that they will first go through the constructive thinking before they come to analytic thinking. Or because these are the analytic thinking is a higher order thinking. Okay. So make sure that you take them through this constructive thinking before they come to the analytic thinking. In other words, allow them to construct their own thinking, to construct their own knowledge before you introduce them to whatever formula or generalization you want to introduce them to. Yes. Any question? Any question? Okay. So I think I've explained this one. This one is still talking about that. It say allow children to develop their concept in a global, intuitive manner. That is, allow them to experience it their own thing. Allow them to construct their own thing. Okay. And we are saying that these argue that it is not possible to analyze what is not yet there. So the child doesn't have that abstract thing and you are going to analyze. No, it's not possible. So let him have that one first, okay, before you teach them what it is, what is not there. Okay. Yeah, I think that's the point Deans is making here. When we follow these things, I think we will help our students very well. So these are the 6 stages of Deans. Yes, this one too, I'll not waste time on them. These are the 6 stages. I think basically, if you put the stages together, we see that we have 3. We have the free play, we have structured, and then we have the formal. Okay, but these are the stages that he came out with. The first one is the preliminary free stage. We have the structured activity stage. We have the intuitive abstraction activity stage, where students compare and things. And then we have the representation activity stage. We have examination and descriptive activities, that's symbolization stage. And then we have the axiomatic formulation activities, or that's formalization stage. Here, this is where we introduce the symbols and the rest, the abstract. Okay, so anytime you are teaching, EMA goes through these stages. Okay, please. So when you go read on the stages, know the characteristics under each of the stage, what goes into each of the stages there. The free play, what should you do? Okay, what should the student be doing? What is the role of the teacher there? We come to the preliminary free stage. What is the role of the teacher? What is the role of the students in each of them? So I'm not going to talk about the stages. Yes. Any question? Any question? And then we come to the real constructivism. For the constructivism, just how we have the constructive principle, constructivism in mathematics education. So talks about the fact that children construct their own knowledge. Okay, children should be given the opportunity to construct their own knowledge. That's all the constructivism is talking about. Okay, allow them to construct their own knowledge. Don't tell them. Don't always be telling them things. Okay, allow them also to talk. Okay, allow them to talk. Okay, so in other words, you are to allow the learner to take active role in the teaching and learning process. Okay, if you play active role, okay, it should not be passive. Involve the children, engage them, okay, on hands-on and minds-on activities. That's all the constructivism is also saying here. Okay, so it emphasizes the importance of active involvement of learners. Yes, I think I've talked about that. Constructing knowledge for themselves. Allow them to construct. Allow them to build the knowledge for themselves. Allow them to build their own ideas. Okay, tell you what is in their mind. They should tell you what they are thinking about, and so on and so forth. You see, when you give this how do you call it? You give your children this opportunity. Okay, you will learn a lot from them. You learn a lot from them because you know how they are thinking. You know what is going on in their mind when the concept is being communicated. So allow your students to also teach you sometimes. Okay, don't always go there and teach them. You think that you have everything. No. Now we are in the 21st century, and the 21st century, the knowledge is more towards what? The learner. Okay, yes, the learner. The teacher is at one side, then the learner is at one side. The knowledge is between. But we are saying that the knowledge should be more closer to the learner than you, the teacher. You, the teacher, should be a facilitator. Okay, helping your children to construct their own knowledge. Any question? Any question? Then we have some people like John Dewey, Morrison, and then David. They are the proponents of this constructivism. Okay, and then they believe that the learner should be actively involved in the learning. The learner should be allowed to discover things for himself, and then he should also be allowed to build knowledge. If you are not talking, you can mute your mic. So you, the teacher, will act as a facilitator and then allow the children to construct or discover or explore whatever you put before them. Okay, so that is all about the constructivism. Any question on the constructivism? And as to whether we practice it in our schools, do we do that? Do we give our children the opportunity to also talk in class? Or you just go there, whatever you have prepared, you talk, and then you go away? What do we do in class? Can somebody share his experience with us, his or her experience? What do you do in class? Do you give your children the opportunity to talk? How do you teach? Anyone? I thought we have some experience. Honest.
Normally, we allow them to talk. So personally, what I do is that sometimes when I give a problem, people will be solving, they'll be getting different answers, and I don't say that this is correct or this is wrong. So when they are all done, sometimes when I have enough time, I ask them to justify the answers. Later, I would say that people are even changing theirs, meaning they are
I'm happy to use that word, justify. You have them to justify. So they have constructed their own knowledge. So you let them justify, you let them explain. Thank you very much. Let them explain. Okay. Yeah. Yeah.
But
okay. Yeah. Ibrahim.
Yeah. For some of us, we hardly apply these strategies because the school asks you to prepare the candidates to write these.
Okay.
At times you find it difficult to, because when you try to put this, the time shadow might not even help. So in that case, how do we go by our?
Okay, Ibrahim. Ibrahim, you have 20 students in your class.
Yeah. Okay.
Okay. You are to cover 10 topics before the exams. Gifty has also 20 people in the class. And he's also supposed to cover 10 topics before the exam, the WAEC exams. Okay, so the school is putting pressure on you to finish the topic. So you are able to finish your topic. You are able to finish your topic. I'll tell you how to finish topic. Then Gifty is not able to finish because his students, he wants them to understand. So he took his time, covered only 5 topics before the exams. When they go for the WAEC exam, which of them will pass? Gifty students or Ibrahim students? Ibrahim students, they were putting pressure on him to finish. So he finished all the 10 topics. They don't understand anything. Now Gifty took her time. He taught it and he was able to cover only 5 topics. And they understood all the 5 topics. So when they go for the WAEC exam, who will pass? Anybody? Miriam? Okay. So I want you to make the analysis from here. I want you to understand that the denominator of teaching is understanding. It's not coverage. The denominator, all that you are doing in the classroom you are teaching is understanding. It's not coverage of topic. If you cover all the topics without understanding, you have done course 90 work. Course 90. Let me tell you the true story here. My elective math teacher, secondary school, finished calculus in 1 period. 1 period was 60 minutes. He finished calculus. Calculus is made up of integration and differentiation. He finished teaching us calculus in 1 period. And he gave access to do exercise. That is all, 1 period. So you think that I will be able to answer any question on calculus? The teaching is not about coverage, please. Teaching is about understanding. Look at your students, their strengths, their weaknesses, and help them to understand rather than coverage.
So the pressure is from the CISOs when they come around.
Yes, that's what I'm telling you.
Blame you that you haven't covered much. So
okay, so you
cover the topic.
You see, you don't use human being for experiment. So that like you experiment it, you cover all the topics and let them go for the exam, and let's see whether they will pass. And let's see what the CISO will say. Whether they will come and see when they fail, they will come and see, check your note whether you covered all. Do they come back to check whether you covered all the topics? They should come back at the exam. They should come back and then see your note. You have covered all the topics so that they will not put the blame on you.
Yeah. Like this time, for instance, I taught only 2 topics. When he came and he was complaining, because construction
the 2 topics that he taught. Why do you teach the 2 topics? Did you go to your school farm? Did you go to the farm? Did you miss the classes? The 2 topics. You see, some teachers are also lazy. You taught 2 topics because you don't want to come to school. You go and do your own business.
No, sometimes the students' ability to understand.
Exactly. So if you are following the pace of your learners, if you are following the pace of your learners, nobody has any to complain. Nobody has to complain. You come to class, the timetable, you follow the timetable. You don't miss class every time you come, and you are able to teach 2 topics and they understand the 2 topics. My brother, look, your student will perform very well in the university. Let them come. Every year, they sack first-year student, the university. Every year, not less than 100 people. You don't hear it. They put it in the daily graphic. Every year from the university, not only here, UCC, all the universities, every year they sack students. Why are they sacking them? Non-performance. They have passed. When you look at their grade, their ISS grades, A in maths, A in this, A in that. At the end of the second semester, they sack them. They can't cope. Who has caused it? The teacher who is just covering the topics with neglecting understanding has caused it. So let us focus on that and then leave this coverage thing. When they come, explain to them. Let the CISO understand the nature of your students. what the type of students that you have. They are not as fast as the other school. Your school is different. So you move at their pace. Help your students. You are not helping the CISO. Help your student and let your CISO understand that you are helping the students. Don't leave them and go and do your business. Go to class. Teach as you are supposed to teach. Let's use the principles that we are learning here to teach. And let's see the result. They may not get the result that you are looking for, SHS, but when they come to the university, they will perform. You can do a tracer study. Track your students who are in the universities and see how they are performing. Those who were helped in the exam and those who got their grade genuinely, you trace them to the university and see what they are getting. Yeah. Any other? Mariam, I see your hand up.
Yes, please.
Yeah.
Please, in addition to what my brother just said, me, for instance, in my school, like I was posted in a deprived area, and the learners, their level is very low. So what I normally do is I don't go about what the CISO at times they do come. But me, I'll just do the lesson plan, all right. But when he goes, it is for me. I follow like what will help the learners. That's what I do.
Yeah, you help them. Yes.
So
but in the lesson note, that help that you are giving, you can also write it as the lesson note. You can also write it so that the lesson note will not be just a formality. You write it, what you are going to teach them. That's what they want you to write as a lesson note. Their plan. You need to plan. Everything you have to plan. I don't like teachers who just wake up and go to class without planning. They think that they have taught for 10 years, 20 years, so they are experienced. No, plan. Read more so that you can help your student. You can guide them. You can facilitate. Okay? You know that even the question that the student will ask, you know everything before you go. So that's the way you will be able to help them. But if you don't have any idea about what your student is asking, how will you answer them? How will you help them? So prepare. Put down some plan. When they come, this is the plan you are using. And you follow it to help your student. Some teachers have just taken the lesson note to be a formality. And they just do it. So some will write the lesson in advance. They will write it like to cover all the term. And then put it down. They don't even use it. They don't use it. So they just put it down so that CISO comes and they show it to them. No, please, let's help our students. Let's help them. Let's help them. Even examples that we use in class. I say, well, one teacher was dismissed from one secondary school that I taught because of examples. He doesn't prepare, so he gets to class and then just give any example. He was teaching quadratic factorization of quadratic. He gave the first example, they couldn't factorize it. He insulted the student. This simple one, he couldn't factorize. He went to the board. He himself could not factorize it. Then he said, oh, there's something wrong with the question. He changed the value. He started again. He got stuck. He couldn't factorize. He didn't know that there are some quadratic equations that are not factorable. They have complex roots. He doesn't know. So if he had planned it from the house, he would have given appropriate or relevant examples that will help the student to understand. So the students reported him that when he comes, he will be solving questions and then he gets stuck. He'll be solving, they don't understand anything that they dismiss him. The headmaster gave him a release that he can't work with him. Let us be careful. So plan, sit down. The examples that you give in class, look for them. Look for the examples. Okay, especially some of the topic like a quadratic. Don't play with it. You disgrace yourself. Okay. And yeah, Adam, your hand is up.
So another thing that we are now facing is the evaluation. Normally, they will bring us a scheme that another body, they will buy the exams from a different body. So it makes us even difficult to assess our own children. Maybe if you are restricting yourself for your children to understand, and a different body may also bring exams at the end of the term. And later they will question you why your students are not also performing. But you even seeing the exams, you realize that the topics that the exams they brought is different from what you are teaching them. And the children may also lose confidence in you when those things happen.
Yeah, I think somebody brought this same idea, this issue last year. It's a big issue. Okay, I'm not against setting questions from outside, but it must be an agreement. Okay, we must agree. Okay, what is most annoying is that these bodies, when they set the questions, you have given them 10 topics to set question on. They will set question to cover only 5 topics. That is not good. It's not professional. Okay, you have given the teachers 10 topics to teach so that they will go and get the topics and the question from outside. Tell the one setting the questions, these are the topics you are giving to the schools, 10 topics. So set questions to cover all. Set questions to cover all. You see, when they do that, you don't have to complain again. When they do that, if you're able to finish 5, your student will get the 5 questions to answer there. They will get 5 questions to answer. Okay. But the dangerous one is that they set questions to cover only maybe 5 topics, and you are not able to cover those 5 topics. Then your student will be disadvantaged. They think that you have not done anything. Okay, that is why it is good that you set the question within. Within, you know what you have covered. So you set questions to cover only what you have taught. Different from somebody sitting outside. So the communication, you need to communicate with the people. Okay, you need to communicate with the people. If we are doing 10 topics, they should set questions to cover all the 10. Or they wait when you get to some part of the, how do you call it, of the 10. Then you communicate to them that, oh, you will be able to cover only 6 out of the 10, the first 6. So that they'll set questions to cover the 6 topics. Okay. They set questions to cover the 6 topics. It's not professional at all to set questions on things that you have not taught your student. No. So what are you assessing? You have taught the person and you want to assess to see whether the person understands what you have taught. And you are assessing what you have not taught. So what are you assessing there? And so that is the issue. That's the problem I have with that arrangement. You can still buy a question from outside, but make sure that they set questions on, or you have to give the one setting the question, the topics that you are teaching the student, to set the questions on it. Okay. Lily, your hand is up.
Yes, sir. It looks like in my district, for instance, is the education office that is giving us the questions.
The questions
at the end of every term. Yes.
Okay.
At the beginning of the term, they give us scheme of work to teach.
Okay.
And then they prepare the questions for the whole municipality.
Okay.
We have sent complaints every term. We complain, yet they repeat the same thing.
No, what are
so
they doing
now
wrong?
We don't know what.
Lily, what are they doing wrong? I want to tell us.
Sometimes they set questions. Yes, they set questions out of the scheme of work.
Those are the issues. Those are the complaints.
There's typing mistakes. There are sometimes they even compress the work so much that the children cannot see.
Good. That's the nature and the structure of the questions.
A lot of things we do have complaints and they are not doing anything about it.
Yeah. So those are the issues you have to raise.
So we don't know what to do again.
Yeah. Okay. There you have a case. Yes, you have a case. There are some students who fail our exams not because they don't know anything, no, because of the nature and the structure of the questions. Because of the nature and the structure of the questions, they fail. And some students also pass our exams. We think that they know it. No, they don't know it. Still the nature and the structure. The questions you didn't set it well, so you have given out all the answers. The student will get 100%. You think that he's good. He's not good. So we have principles that we follow when we are setting questions. These people who are setting the question, do they follow those principles? That is what we must be concerned about. Okay, so you have a case. You need to draw the attention to those issues. Okay, those issues are very important. Very important.
The money they are getting.
It's not the best. It's not the best. Not the best. Yes, definitely. Your hand is up. Definitely. Okay, Mara, go ahead.
What Madam Lily just said about the district giving us scheme of work and certain. Yes, mostly when they bring the questions, they are always full of mistakes. And sometimes they will take the question out of the scheme that they have given you. So what I normally do is that I'll look at those that they brought and it is not in the scheme. Then I'll set my own questions and add it to the ones that I have taught them, so that I'll be able to cover it up, so that the children will be able to write the end of term or end of.
No, I don't get you well. Marian, come again. They have brought the exams for your people to write.
Yes,
and you take the question.
Yes, the ones that are not supposed to be taught, like let's say what she's saying that they bring some of the questions that It's not in the scheme.
The scheme.
Yeah, the scheme of learning for that particular term.
Yes.
Yes, and they'll bring questions covering those things.
And what
yes, what I do is that I go to my head teacher, complain to him. When he always give me advice that, oh, I can go through the past questions and see the topics that I've taught, or the scheme, like I said, the topics that are in the scheme, and I know that I've taught them. I should get questions to set so they're able to help the students to be able to answer the questions for the
I still
term.
don't get you. They have brought the question from outside to your student to write.
Yes,
now some of the questions are not within the scheme. So there and there, what do you do? Do you allow them? Do they write it or they don't write?
No, we do change it. We change to the level of what you have taught them.
No, that one you can't do that. You can't do that because the district want to compare. They want to do some comparison. That is why they are setting the question. So you can't change the question there. Rather raise the issue so that they do the writing.
Yes, sir. We do go to the district office and complain. We complain just like.
I don't sit in your school and change only your school questions. No, don't do that.
Okay, sir.
Then tell your headmaster to write to them that your school will not take part, so that you yourself will set question for your student. But when they set it from outside, they are bringing it. Don't change them. Allow them to wait. If you have accepted that you want your school to take part, right? If you change only your school, then that's also wrong.
So it's the whole municipality, and your school cannot opt out. It's compulsory that you must all take part.
Good. So whatever they bring, you all have to take it. Don't change it for your school alone. Don't change it for
and if the students don't perform, their parents will not understand it. Even the education office will say you are not performing. That is why you have the issue.
So rather tell your headmaster the issues with the questions. Let the headmaster know that these questions are all problematic. Look at this one, question 1, question 2. They are not in the scheme. Your headmaster will support you, will defend you when the parents come. That these things were not in the syllabus, were not in the scheme, but they set question on them. That's why the student did not perform. Your headmaster will support you. Okay. So they are
sir. Thank you.
Issues. Yes, you can raise them. If they don't want to listen to you, you let your headmaster be aware, and then you do the writing. You continue doing your teaching. Okay, the way you should do it. It's a very serious issue. Maybe one of you must be at the top to change things. I know when you also get there, you do the same thing. Why would these people who are talking right now, all of you, when you get there, they give you the CISO, you also do the same thing. You will be putting pressure on people to finish. You see the way the world is. So who will change? Who will bring the change? Who will be an agent of change for us?
Master, this one mostly is coming from the district director. So
yes, so I'm saying that Maria, if they give you the district directorship, if they make you a district director, you do the same. You do the same thing. You will not bring any change. Why? Why is this?
I wouldn't do that because
I will not do that. Me, I will never do that.
Are you sure?
Yes, sir.
Yes, I will never do that.
So you'll be the first to change, to bring the change. When you go there and they say, this is what we always do. This is why we do. Every district, every time we set questions for schools, this is what we do. Wouldn't you follow the same thing?
Master, please, in our district here, they set a committee, like we have the science department, the math department, and whatever. Yeah. So the previous director that was there, when it's getting to end of what term, they call those subject teachers. They come together, then they'll set questions. They'll set questions and choose the one that is more appropriate.
Yeah.
Then they'll bring it out for the schools to what?
To write.
For the schools, yes. But a different one came, he said, he's also doing his own thing because of the money.
Okay.
And we have complained. Still, it's still happening.
Oh, no.
So that's what I'm saying. It's only coming from the district directors.
Yeah, it's not the best. I like the first idea where the teachers will come together. They are the people teaching, so they should set the question. But then we have rules, we have principles that we follow. These teachers who are setting the question, do they know the principles? They must also use the principles in setting the questions. Okay. Sometimes we set the questions, the answers, the options are even heavier than the stem. No, you make the stem short, and then the options A, B, C, D, they are wordy. No, you need to confuse the students. Okay. The essential thing must be in the STEM. So the options should be short, so that the student will read and then be able to answer. So there are principles. Okay, we need to arrange the answers in alphabetical order. We need to arrange them in order of magnitude. We don't do that. So we give out the answers. There are rules that we need to follow. And so those who set the questions must follow the rules. If they are following the rules, I have no problem. Okay, if they are following the rules of assessment, you set on what you have taught the students. You don't set on topics that you have not taught them. Last year when I was teaching this, students said that, yeah, UCC, we like doing that. We set questions on things that I say it's not true. It's not true. You set application questions. It doesn't mean that it's outside the course outline. No, whatever you are giving you, yes, the topics are there, but you have to apply. So if you are talking about the application, then you have no case. But for me to leave the course content and then go and set on a different thing for you, that's unprofessional. We don't do that. I have not seen that before. Stephanie, your hand is still up.
Sir.
Yeah.
Sir.
Yeah, go ahead.
In our district, they bring the end of term on third term.
Okay.
But our school, we have decided, because when we get the questions, they cover the topics with the whole scheme and the activities too. Sometimes we have sports and those things. So some of the topics we are not able to do it. So what our school have decided with the headmistress, the office, what they need is the money. So we just send the money for the people, but we don't write their papers. That's what we do. We set our own question within the school. But for them to not have any problem, we just go there to buy the questions. But we don't write.
Okay. Does it mean they don't come for the papers to score? You do the scoring yourself. When
yes.
They say the question,
when the office brings the yes, it's the teachers we are going. They will bring the question and the marking scheme. We will mark and do our own scoring.
They don't come to ask of the papers too. They don't come back and ask of the papers, bring the papers and so on. If they don't ask, then fine.
That's what they normally do. When they bring the papers, they bring the marking scheme. Mark and do everything.
Okay, that's fine. That's fine. That's
we
fine.
don't do that.
But it is good for you to also expose your student to the external assessment, external, because they at the end they will go and write the external. So it is good. That's why I say I don't kick against it, but it must be done well. Okay, it's good to expose them to the external. There are things that they will learn from the external assessment as well, rather than the internal. Okay, and so let us be careful. They all have their pros and cons. Yeah. Lily.
Sir, I want to find out from Stephanie whether it's the school that bear the cost of printing for.
Yes, it's the school that bear the cost.
The school bear the cost.
We do
it means that the school is buying it from outside.
No, for the internal, we set our own question, we print it because the school is having a printer.
But the one that they bring from outside. The one that they bring from outside.
We send the money to the office and go and buy the question. We send the money to the office for the question, but we don't write.
I see. It's because your school is having a printer. Hey.
I don't understand. Okay.
For my district, for my municipality, parents will even go and report.
For this term, as we are in, we have already done with the first exams. We always do reshuffling. We have grouped the learners into 3 categories. We have the high, the average, and the low. So we always write 3 exams within a term. Then we do reshuffling. So if you are from B to A or from C to A, we give you an award, exercise with textbook. But if you are from the A, the high class to low class, we give you a punishment. So we have that competition.
Zeppelin, how will your child feel if he or she is in the lower class? How will your child feel if he or she is in the lower class? The class that you are saying these people don't perform, they are poor, they don't know anything. How will your child feel when he's there? That's another issue. I don't want us to talk about it now. That type of segregation should stop. Mix them up for them to learn from each other. Okay, but that's another topic. Let's leave that. I don't know how your child will feel when you put your child in the lower class. Okay. So we'll not talk about it today. Okay. And any other issue? Any other issue? Okay. And so the application of the constructive, the teacher should tailor teaching strategies to student responses and encourage students to analyze, interpret, and predict information. Yes, so these are some of the application of the constructivism theory. Okay, that we must allow the children to explore. We must allow them to how do you call it? Experience whatever we have for them. And then the teacher and the learners can negotiate meanings. You see that then they can negotiate meanings of actions and words as they interact. So don't just go and tell them everything. You can discuss with them, put them into groups to discuss among themselves and so on. Then learners must also be encouraged to verbalize the mathematical thinking. They should tell you, okay, explain their reason. They should justify whatever they have and so on and so forth. And then through this, you are able to identify some errors and misconceptions that your children have. Okay, if you allow them to verbalize, you allow them to explain, you allow them to justify what they have, you will see that your students have some strong misconceptions. And these misconceptions are very difficult for you to convince your students. They have formed it already. They know that that is the truth. It's very difficult for you to change misconception. And for errors, you can easily change. It's by a mistake or some careless something. But the misconceptions, when they are formed, very difficult for you to change them. So it is through this explanation and justification that you identify that, oh, my students have some misconception. And then quickly you change them. Okay, the teacher always teach 2x plus 4 is equal to 8. So you want to find x. Okay, so 2x here, this one, 8 minus 4, that will be 4. So you divide both sides by 2. Yes, and cancel. And that is why when the children went, they give them sine x is equal to 0.5. They say they should find x. The students were also dividing by sine. They divide both sides by sine. So you see here, they are forming misconception. So the sine will cancel sine, then you will be left with your x. So your x is equal to, then they say sine inverse of 0.5. You see how we have confused the student. So if you allow the student to explain his answer, you understand what the student is doing. You understand what the student is doing. Is the student right? Is the student right? The student who worked it that way, is it right?
Yes.
The student is right.
Yes.
The teacher has taught 2x is equal to 4. So to get x out, you divide both sides by x. So this side by 2, this side by 2. You divide both sides. So the 2 cancel 2. X will be equal to 4 divided by 2. Now the student has been given sine x is equal to 0.5. So the student said that to get the x, you divide both sides by sine. So this side by sine, and then this side also by sine. And so the sine here will cancel the sine. X will be equal to 0.5 over sine. Then you find that. Is it right? Is the student right?
Yeah.
The student is wrong. About why?
Yes.
Look at what the teacher taught.
The student is right.
So the student is right. Is the
student is right.
Yeah. Yes.
When it has to do with sine and cosine, you take the sine inverse, not.
Yes, so the student is saying that this one means sine inverse. So you see, when you do this, it means that it is 1 over sine, then 0.5. So he's saying that that's sine inverse. Is it not right?
Is that when we are teaching this, we should allow the student to know that when we want to find x, this means that we are multiplying both sides by the inverse of that coefficient over there. So that when we
like,
get to the
look at what the student has done. Look at the last point. He said this, the 0.5 over sine is the same as 1 over sine times the 0.5. Is the student not right?
To the student will be right. To the student.
If it does this one, it's right.
Yes, the student is right based on what we taught when we were doing the 2s equals to 4. Though the answer is wrong, but the student is following the first approach. Yeah. That is why we said when we are teaching, we should use abstract and dynamic formulas for them to understand what we are doing.
So this one, what did the teacher do wrong? What did the teacher do wrong before?
The teacher should have explained further to the child that this he has done here 2s equals to 4 is the same as the multiplying both sides by the inverse of the 2.
Yes.
So that like
and
it will be
what the child has done there, and he's telling you 1 over the sine is the inverse. Oh,
No, what the we don't divide sign.
We don't divide sign. So what he
No.
has done is not right.
No, he's wrong. To him is right, but is not the proper way of doing it.
Go to sine inverse of 0.5. Is that not the sine inverse of 0.5? Can you see my screen? Let us say 1 over sine 0.5. Is that not the sine inverse?
1 over sine is inverse.
It's the inverse. So I can write it as this. Can I do this?
Yes,
can I do that?
Yes.
Yes. You see, if you, the teacher, you don't know the concept, there's no way you can help your children understand. So this thing that the child has done here is wrong. It's wrong. 1 over sine theta is cosec. It's not sine inverse. 1 over cos is sec. It's not inverse. Please, let's take note. So 1 over sine is not the same as sine inverse. Please. So if you don't know this, that the student will just present this for you and then you mark it and you give him all the marks. You think that he is good. He gets to the university, then he will be sacked. Let us understand this concept. So 1 over sine is not the same as sine inverse. Not true. Please, are you okay?
Yes, sir.
Okay.
Yes.
Okay. So 1 over sine is cosec. 1 over cos is secant. 1 over sine is not the same as sine inverse. No, not at all. So let us be careful. Yeah. So rather, when you are teaching this thing, let them understand that the sine theta or the sine x, cos x, tan x, all of them are functions. All of them are functions. If you have a function, say f of x, and you want to get to the x, you want to remove the x, then you need to multiply this one by the inverse. You need to multiply by the inverse function. If you multiply by the inverse, then you get x. So anytime you have sine x, it is a function. So if you want to get the x out, then multiply this one by the inverse, sine inverse. That is the only thing that can give out the x. Okay? So that when they are giving the sine x is equal to 0.5, and then you ask them to find x, the only time or the only way you can get the x out is to multiply both sides of the equation by the sine inverse, so that you get the sine out. So sine inverse. Then you do the same thing here, sine inverse of 0.5. So let them understand that all these ratios as functions. Functions. Okay. Okay. So once again, 1 over sine theta is not the same as sine inverse of theta. Not at all. Please. 1 over sine theta is not equal to sine inverse. 1 over sine theta is cosec. 1 over cos theta is sec. Okay. That's good. Any question? Any question? Okay, so those are the applications, and then allow learners to assess themselves. That's another constructivist principle. Allow the learners to assess themselves, not you always assessing them. Allow them; they should assess themselves. Okay, yes, they can assess their colleagues and so on. That's a constructivist. Then the teacher use the alternative assessment form, which encourage use of variety of instruments. Okay, alternative assessment form. Don't base your assessment on only one mode. Okay, try to change them a bit so that you help your students to cope with whatever you are teaching, or you'll be able to get a holistic picture of your students that you are teaching. Okay, any question? If there's no question, then we'll bring this unit to an end. I'll share the slide with you, and then we'll go through all distill the application and question time. Any question? Any question? So this unit talks about the theories of learning or teaching. So there are some self-assessment questions on the slide. When you get it, look at them and see. So when we mention Piaget, if you ring bell, you must know what Piaget is, or everything about Piaget. When you mention Gattegno, you must know what Gattegno means. When you mention Gagné, Robert Gagné, when you mention Brunner, when you mention Zotandins, you must ring bell. Okay. That's it. Any question? Any question? Any question? No question. Can you hear me?
Hello, sir.
Hello, yeah.
So I wanted to ask you on the assignment you said we should work on it. Is it yes, sir. Is it length of an arc or
what
sector?
No. I gave both. I said both. The length of an arc and then the area of a sector. I gave both.
Okay,
the length of an arc. Then the second one, the area of a sector. The formula.
Okay, sir.
I'm saying that you describe an activity step by step. Okay, how you help your learners or your students to come out with that formula without giving it to them. Through the activity, they will perform the activity and then they will come out with the formula.
Okay, sir.
Yes.
Thank you, sir.
You're welcome. Any other question? Okay. So maybe
hello, sir.
Yellow winning.
Secondly, the slide you used today, it seems a bit different from what Isa posted to us because
I've given you. Yes, I give you the slide.
Yeah, there was one of the principles like that. It was not in the slide that I took from Isa.
Oh, okay. Okay.
Yeah.
Okay. Which one was that?
It was
constructivist principle.
No, the multiple
embodiment. Okay. Okay, multiple embodiment. Okay. I see. But you read on that, the multiple embodiment principle.
Okay, sir.
It's all there. It's all in the slide. They are all there. The one that I showed you, they are all there.
I think what you are using is a revised form of the one that we have. I think what we are having is those who used it last year, 2024, because I could see.
It's not. When revised means we have added something new. No, there's nothing.
That is why we are saying that there is a disparity.
There's no disparity. I'm teaching the course. I'm telling you everything is there. Look at the slide very well. The multiple embodiment. Anybody who has a slide, you tell me multiple embodiment is not on the slide. Anyone before I close. Check it.
There, sir.
It's there. I'm teaching the course. I'm saying it's there. Is the position I have changed. I have not revised anything there. Everything is there. I have just cut the multiple embodiment and put them under where we have the principles. The multiple embodiment came before the other ones, the dynamic principle and so on.
Yes, sir, it's there.
They are all there.
Yes,
so
sir.
There's no disparity here, please.
Is there? It came before the
Exactly. Just this morning that I was going to teach, I just cut them and put them under the principles. I just cut it from the top and bring them down and brought them there. So there's no disparity, please. Okay. Any other question? Any other question? Okay. Then we'll end it here, but I'll share the next slide also. The next slide that we'll do, I will share it so that you read before we come. Then when we come, we'll move faster. Okay, we'll move faster. Okay. Thank you very much. Have a nice day.
Thank you too, sir.
Yeah.
Thank you too, sir.
Bye. Bye.
Bye.
Guys, please, are we done for the day? For the first session?
No, we are done for.
Thinking of.
It's left with algebraic
Yeah,
thinking.
11:50.
Please, group 3, are we meeting for the algebraic thinking? The questions that Madam posted last night. Group 3.
Yes, let's meet.
Mr. Dominic, are you there? Are we meeting?
Some of us we joined yesterday. We are not in these groups. How can we be part of the groups, please?
Mr. Isa will do that for you.
Sorry?
The class rep.
All right. Thank you. Hey, sorry, my network failed. Are we done?